Hey everyone! Today we are tackling a classic calculus question. We're looking at a region bounded by a curve, y equals the square root of x, and a line, y equals 1 over 3x. We are going to spin this shape like a top, first around the x-axis, then around the y-axis, and calculate the volume of the 3D solids they create. Ready? Let's go! Before we spin anything, we need to know where the shaded region starts and ends. We find the intersection points by setting the equations equal to each other. Square root of x equals 1 over 3x. Square both sides to get x equals 1 over 9x squared. Moving everything to one side gives us x minus 1 over 9x squared equals 0. Factor out the x. X times the quantity. 1 minus 1 over 9x equals 0. This tells us our boundaries are x equals 0 and x equals 9. To find the intersection point, we can plug our x value, 9, back into either of the original equations. Since they intersect at that exact spot, both equations will give us the same y value, which is y equals 3. So our region is between 0, 0 and 9, 3. Those are our limits of integration. For part A, we rotate around the x-axis. Because there's a gap between the shape and the axis, we use the washer method. Think of it like a donut. We find the volume of the whole thing and subtract the hole in the middle. The formula for the washer method is volume equals pi times the integral from a to b of the quantity, outer radius squared, minus inner radius squared, dx. So our outer radius is the top curve, y equals the square root of x, and our inner radius is the bottom line, y equals 1 over 3x. And we know that our limits are from 0 to 9. Let's plug those functions into the washer method formula. Volume equals pi times the integral from 0 to 9 of the quantity, the square root of x squared minus 1 over 3x squared dx. Now, simplifying that gives us volume equals pi times the integral from 0 to 9 of x minus 1 over 9x squared dx. Next, we integrate each term. For the first term, x we get 1 over 2x squared. As for the second term, negative 1 over 9x squared, we get negative 1 over 27x cubed. So our integration is pi times the quantity, 1 over 2x squared minus 1 over 27x cubed, all to be evaluated between 0 and 9. Since both terms have an x value, so substituting for 0 would result in 0. In this case, let's concentrate on x equals 9. Pi times the quantity, 1 over 2 times 9 squared, minus 1 over 27 times 9 cubed equals 13.5 pi. So the volume of the shape when it rotates around the x-axis is 13.5 pi cubic units. Now part B, we rotate around the y-axis. This changes our perspective. Everything must now be in terms of y. At first, we rewrite the functions. For y equals the square root of x, then x equals y squared. This is now our inner radius. As for the second function, y equals 1 over 3x, then x equals 3y. This is now our outer radius. In addition to rewriting our functions, we also have new limits. In the previous step, when we set the equations equal to each other, our stationary points were x equals 0 and x equals 9. We also found that when x equals 9, y is equal to 3. Therefore, our new limits for the y-axis are y equals 0 to y equals 3. Let's set up the integral. Volume equals pi times the integral from 0 to 3 of the quantity 3y, all squared minus y squared, all squared, dy. Simplifying the integral we get volume equals pi times the integral from 0 to 3 of the quantity 9y squared minus y to the 4th power, dy. Let's integrate now. 9y squared becomes 3y cubed, and I to the 4th power becomes 1 over 5 to the 5th power. So our integration is pi times the quantity, 3y cubed minus 1 over 5y to the 5th power, to be evaluated from 0 to 3. Again, both terms have the y term, so evaluating y equals 0 will result in 0. Therefore, let's focus on the upper limit. When I equals 3, we get pi times the quantity 3 times 3 cubed minus 1 over 5 times 3 to the 5th power. This is equal to 32.4 pi cubic units. And there you have it, 13.5 pi for the x-axis volume and 32.4 pi for the y-axis volume. If this helped you understand this question, hit that like and subscribe button for more step-to-step math tutorials.